Hello, all of you. Today we'll revise cloud computing architecture that we had seen in last few lectures. In this, we'll see requirement cloud computing architectures, SOA, grid and cloud computing, then distributed computing. First, we'll start with some scalability, efficiency, and legal issues for businesses are the reason for the cloud computing. Then, main requirement are data storage, distribution of these data are basic need, like high performance computation is one of the basic need. Transaction computing means transaction could take place. Then caching of the data, thereafter workflow of data, which has different procedures, access control, service level agreement for requirement, then changing in enterprise industrial environment in the role of customer, provider and ISV. So various changing roles of customer, provider and ISV is the necessity for the cloud. Then architectural elasticity are also the need and necessity of the requirement, like vertical scale out, horizontal vertical scale up, horizontal scale out. Is it audible? Is it clear now? Is it clear? Is it clear now? Hello? Hello? Okay, I think it's improper connection. So various requirements that we had seen for cloud computing architecture are basically scalability, efficiency, legal agreement for business. Like data storage is one of the major requirement. High performance computation we had seen is the major requirement. Transaction computing, caching, workflow, access control, and service level agreement that we had seen. All these things are the major requirement behind cloud computing. And there's also one important requirement, like changing of customers and provider and ISV behavior and functionality and necessity and needs. So these changes in industry and enterprise are also cause for creation of cloud computing. Next, the most important scalability feature that we see as elasticity means increasing number of resources. That could be of two type: vertical scale up and horizontal scale out. In the vertical scale up, various computing resources are being added on the single computational power, and that will keep on having high end machine, one high end machine. Next, horizontal scale out is basically keep on adding new resources at at another location or with another machine, and all these machine are being combined together and being processed. So what is difference between job processing? In the vertical scale up, job is being sent in the single machine with high resource, whereas in horizontal scale out, that job is being sent to the multiple machines in a distributed manner, and then this distributed database being processed, and then result of that each machine would be combined together. And this is why for HPC, horizontal scale out is better than vertical scale up. And vertical scale up is also having high complexity in adding more resources to the single machine. Thus we are studying horizontal scale out for cloud computing. Next, cloud computing architecture and their roles of various actors we had seen. There are basically we had seen five roles and responsibility and activities and functionality of in the cloud computing. What are these basic characteristic requirement and use cases of cloud computing? So high level architecture we are seeing in the diagram, like cloud carrier are the network providers, and they have various switches management and server management type of things. Whereas cloud provider is the main service provider, which could be divided into multiple parts like infrastructure as a service, platform as a service, software as a service. So all these services are being orchestrated, means combined together, managed to function in between all the three, and then this is called service orchestration. And then resources abstraction is one of the infrastructure as a service providers responsibility. Then we have seen various physical resource layer is being abstracted at the hardware and facility level. Then service provider like cloud provider has cloud service management with business support, provisioning, configuration management, and portability, interoperability. All these things are being managed. Then security and privacy are being managed between all these things, cloud provider. Then cloud auditor is basically the security auditing feature, privacy impact auditing would be done, performance auditing would be done. So this is the functionality of cloud auditor: security, privacy, and performance auditing. Then cloud broker is one of the intermediate actor, and that has functionality of service intermediation, service aggregation, service arbitrage, which communicate with cloud consumer and cloud provider. So cloud consumer are basically like we all the students and all the teachers and all most of us are like cloud consumers. So it is very clear who are cloud consumers. Next, we have seen on-demand self-service, broad network access, resource pooling, rapid elasticity, measured services. So how these characteristics behaves means for the whole cloud computing, these are the five characteristics which are being managed by different cloud computing actors and being managed for cloud services. And for example, on demand means how much a customer want to use, how much broadband network is required, how much resource is being required for processing that particular task. Then scale out means how many resources we have to add for that particular process. Then measured services, that services are being measured. Next, actor in the cloud computing. Actor in the cloud computing are the basically the five things that we had seen: cloud consumer, cloud provider, cloud auditor, cloud broker, cloud carrier. These are been acting together and they have different definitions we had seen. Like consumer are the simple business usage person or an organization. So cloud consumer are those. Cloud provider are organizations or persons or a government body that actually provides some service to the cloud consumer. Next, cloud auditor basically a third party which manages auditing features, security, performance independently for accessing the cloud service. And then broker is basically intermediate part that behaves negotiation between the relationship between the cloud provider and consumer. Cloud carrier is basically having the intermediate and the lowermost network provider part, which actually acts between cloud provider and cloud consumer. All the five have their importance in the cloud computing architecture. So we have to give means appreciation for each of the actor. Next scenario one we can see that cloud consumer is been communicating through cloud provider one and cloud provider two using some cloud broker functionality. Cloud consumer interact with the cloud broker instead of the contacting a cloud provider directly. Then cloud broker may create a new service like mashup and by combining multiple services or by enhancing an existing service. So cloud broker basically combines different services and mash up these services and enhance some particular service to provide it to the consumer. Then actual cloud provider are invisible to the cloud consumer. Next type of scenario that we had seen is cloud consumer having two different service level agreements with cloud provider and cloud carrier. So provider has two different service level agreement with cloud consumer and cloud carrier. So this is also one of the scenario where different service level agreement is being managed by different entities in the or actors in the cloud computing architecture. Next, we had seen cloud consumer and cloud auditor and cloud provider are being connected together such that cloud auditor is been evaluating cloud providers cloud services and then it reports to the cloud consumer that these are the services good and these are the services which has breached some of the service level agreement which has not followed some of the service level agreement. Next, we had seen details about the cloud consumer. Basically cloud consumer is using browser or Android app or iOS app for accessing some of the service. Then consumer is being set up for the contact with the cloud provider. Then service level agreement is being fulfilled for the performance of the cloud provider. The service level agreement covers quality of service, security remedies for performance failure. A cloud provider lists some of the SLA service level agreement that limit or obligate the cloud consumer by accepting some of the features. Then cloud consumer is basically choosing different cloud provider for different services and based that choose choice basically depends on pricing or favorable condition for the cloud consumer. Then we have seen there is pricing policy and service level agreement are being negotiable between the cloud consumer and provider or various actors in the cloud computing. So these are the features of and usages of cloud consumer. Cloud consumer could be of three type: IaaS consumer, PaaS consumer, or SaaS consumer. So IaaS consumer when it uses storage, CDN, backup recovery, service management, platform hosting, and computation. PaaS consumer basically uses business intelligence database developing testing environment, application deployment environment, integration. Then SaaS consumer basically uses document management system like Google Docs, emailing system, CRM, sales, billing, social networking, finance, human resource, all these things. When SaaS consumer uses, then it's having property of SaaS consumer. Any of the features that a consumer or a user uses, then it becomes SaaS consumer. Like human resource functionality, it uses social networking, it uses document, it uses content management, it uses. Next, SaaS consumer, we'll see what it is in detail. Like SaaS consumer are basically accessing software applications and software applications then for the administration purpose and then managing could be done by the end user itself. So this SaaS consumer is basically like Facebook user, Twitter user, Gmail user. We know very well this SaaS user. Then consumer is also been built according to the number of end users and the number of the time it uses, bandwidth it consumes, data storage and duration how much that storage is being used. So these are the way to build SaaS consumer. Next, PaaS consumer. PaaS consumer is basically uh, deploy some of the application and administrate those application and uses some of the PaaS platforms for deployment of that application. So PaaS consumer basically design and implement applications, software applications, and also test those software application and run those application, and then after that it deploys or publishes that application on the cloud on some platform it deploys. And PaaS consumer also does configuration and management of and monitoring of that application. How PaaS consumer are being built? PaaS consumer are being built based upon the processing, database storage, and network usage ways and that it consume. So PaaS application are being deployed and PaaS consumer is built upon the usage of that PaaS application. So how much the PaaS application is being used, the PaaS consumer is built upon according to that. Then the duration of the platform usage for the PaaS consumer. Then IaaS consumer is basically the system developer, system administrator, IT manager who are interested to creating and installing and managing and monitoring services for the IT infrastructure operations. So IaaS consumer is basically fundamental computer science guys or fundamental computer science intelligent engineer and experts that uses IaaS. And that type of people are called system developer, administrator, or managers. And they actually deal with core IT technology for creation of various IT infrastructure, installing some of the software and monitoring some of the services. Then how this IaaS consumer are being built? This IaaS consumer are being built according to the amount of usage of the resources hardware which has been used and the CPU hours which has been used, then volume of the data it has been used and the duration for what that data has been stored, the network bandwidth consumed, IP address has been allocated for the various images of machines. Next, cloud provider. So this is second actor that we'll study. Cloud actor basically acquires and manages the cloud computing infrastructure required for providing services. So what it does, cloud provider actually provides basic services like what it provides. It provides software as a service. It provides platform as a service, infrastructure as a service. So these three services are being provided by cloud provider. What type of services it provides in SaaS? So SaaS, when deployment and configuration and management and updation of operation could be done by someone, then it is SaaS provider. And SaaS provider basically maintains service level agreement and at the topmost application layer. What is PaaS provider? PaaS provider manages computing infrastructure, platform, and components, and that runs some software execution and databases and middlewares. Next, infrastructure as a service cloud provider. What it does hardware management, fundamental cloud software management, and then provisioning of those infrastructure services like physical server, network equipment, storage devices, hosting, operating system, and hypervisors are being done with this IaaS cloud provider. So these are the five basic activities of cloud provider, like service deployment, service orchestration, cloud service management, and security and privacy of that service are being managed and delivered by cloud provider. So cloud provider has these five activities for consumer. Next, we'll see cloud auditor. What this cloud auditor do? Auditing various performances in cloud computing like security, privacy, and performance. And then cloud auditor are basically important for federal agencies like government agencies or some some department in an organization or some some federal agencies. Next, security auditing. What it does in security auditing, security control checks, how the services are being operated, what are the intended operation purposes for that service, then whether it is having desired security features or not. So all these verification and compliances are being done for the regulation and security policies. Next, privacy auditing. So what it does in privacy auditing, like federal agency comply with applications of privacy law and regulation governing an individual privacy to ensure the confidentiality, integrity, and availability of individuals' personal information at every stage of the development and operation. So these are the basically features what it provides at the fundamental level. Privacy and confidentiality, integrity, availability are being managed by the cloud auditor for checking privacy of cloud service provider. Then cloud broker. Cloud broker, what it does integration of various complex services that are required for the cloud consumer. And then it manages the performance and delivery of various services, negotiate between the cloud provider and consumer. Then there are the three basic features that cloud broker does: service intermediation, service aggregation, service arbitrage. And then the service broker enhances the service for improving capability, providing value added services, and consuming all these services, and then managing those services, identifying management. So these are the property of intermediation. Service aggregation means multiple services are being combined together and being having the data integration and ensure the data monitoring and security purpose for the service aggregation. Then service arbitrage is basically simple aggregation of the flexibility of choosing multiple agencies. Then broker can select basic service requirement for response purposes. Cloud carrier are the consumer for network. Cloud carrier actually provides services for the consumer like network, telecommunication, and accessing the devices. So this cloud carrier is hardware network manager. For example, this cloud consumer is basically having network access device such as computer, laptop, mobile. So all these things are being provided some network features for these laptop, mobile, and internet devices. Then distribution of these cloud services for management of network and telecommunication for basic purpose. What is basic purpose on internet? Transportation of packets, and different transport agents were there for this purpose for business organization communication with physical transportation. What are the example of cloud carrier? Airtel, BSNL, Vodafone. Next, who are the cloud carriers? Cisco, Juniper. These are the hardware provider, Motorola. And then cloud provider can set up SLA with a cloud carrier to provide service consistently. So there could be different service level agreement with the cloud carrier for providing a quality of service which is being offered by cloud provider to the cloud consumer. So we'll see scope of the control between provider and consumer. This is the scope of the cloud provider and consumer. So application layer, middleware, and IaaS layer. If we start from cloud provider, from the bottommost layer, so we'll see that operating system, middleware, and application layer are the features in the fundamental computer science. So operating system level of feature are being used manipulated by infrastructure as a service provider. And then middleware like things like platforms for deployment of services or some web application are being managed by platform as a service provider. Then application layer are being managed by service provided by the software as a service provider. So software as a service provider manages the application layer things. Who are the consumers? The cloud consumer are basically of again three types: SaaS consumer, PaaS consumer, IaaS consumer. SaaS consumer actually uses application layer softwares like Facebook, Twitter, LinkedIn. Then cloud consumer basically uses platform as a service platforms like Docker Hub, GitHub. All these things are basically having some software related thing and that has some platform for managing that deployment of like Ruby on Rails, Google App Engine. So that are the cloud provider which are being used by cloud consumer, like like platform as a service consumer. Then infrastructure as a service provider examples are Eucalyptus, like Open Nebula. So these are being used by the organization for deployment of a private cloud infrastructure, and that are the cloud consumers. So what does it mean? So the layer of applications layer is being used by SaaS consumer for installation management done by the PaaS consumer and IaaS consumer. Then SaaS provider also provides some of the features to the SaaS consumer. Then middleware layer is being used by PaaS consumer, which are having features of installation management and maintenance done by the cloud consumer. So cloud IaaS consumer does installation management and maintenance, and also PaaS provider. So it was being used by the PaaS consumer. Then middleware is basically hidden with from SaaS consumer of this layer. Then lowermost layer infrastructure as a service layer. It consumes s- software as a service. It has been used by software as a service consumer, platform as a service consumer. So this layer, infrastructure layer, is being used by SaaS and PaaS consumer. Then it gives this consumer gives freedom for choosing different operating systems being hosted at infrastructure layer. Then various kind of cloud computing architecture are Web 2.0, Mashup, RSS feed, Hadoop, HDFS, Storm, various cloud, Google architecture, Eucalyptus, Ruby on Rails. Web 2.0 are basically having features like Web 2 home pages, different high-end home pages. Search engine is being improved. RSS feed is one of the important feature of Web 2.0. Chat box, sharing of data, personalized web services or personalized websites, mashup of different web services, then podcasting, video casting, YouTube channels, and different video mediums. And these are all the feature of Web 2.0. Then community and collaboration for programming, development, and documenting things are the feature of Web 2.0. What is mashup? Mashup is the phenomenon for combining different services to make a new service with combined functionality and presentation. Then what are the benefits of mashup? Benefits of mashup are basically innovative new business insight, agility. It reduces the development cost. It is easy for integration, and there are different reuse could be done for that software. Intermediate benefit could be there with that mashup. Less cost would be there for a mashup feature. Then original raw data sources are required. Procedures are being required for resulting data and services. Then mashup is being divided into three different layers. And what are the three different layers? Similarly, like infrastructure, like platform, like present, like topmost application layer. So similarly, these mashup are being divided into three basic layer. First one is presentation based upon HTML, CSS, or different APIs. Then web services running in backend. What are these RESTful web services, SOAP-based web services, old type of RPC or XML RPC. Then data standards like XML, JSON, KML are the data standards working for the mashup. What are the RSS feeds? So RSS feed are the basically written in the XML language for syndicating subscribed content. Means it synchronizes between the information provider and the information user. Who are the information user? Suppose we are the information user, we want different news feeds from different news channels. So what we do RSS subscription for the that feature. What it does, register with the organization for accessing those RSS feeds by that organization. So we need to do what? Registration with that organization for the RSS feed. How it does? It does automatically updation of the news or notification or the information by that provider or organization. Next, the information is being received quickly at different location at a particular same location by different type of organization. So we get information of different organization at the same location at the same point. Next, we'll see Hadoop. Hadoop is one of the most important and most common cloud computing middleware. What it does basically distributed computing, which is scalable and reliable. And what is Hadoop? Hadoop is basically open source software developed by Docketing, and name of his and named over his son like Hadoop. And then Hadoop is basically library or the framework which are being used, and this is having large data set working over the different computers having connected over the different clusters for for a simplified programming model. So locality of reference is important thing we had seen. Scalability, we had seen that there could be 10, 100 or thousands of node working together for a storage and computation purpose like a single machine. And then corresponding performance improvement would be seen for with these multiple connections. Thereafter, we'll see fault tolerance in this Hadoop, which can handle failure and deliver high availability of the services. Then Hadoop distributed file system is the basically database used for this purpose. And modeling this model Hadoop distributed file system is based upon Google file system for, and it has map reduce feature for parallel computation. And it what are the component it has, like Pig, HBase, Hive, or Zookeeper. Next, Hadoop distributed file system are basically having this type of architecture. Like name node is being connected with the various data nodes. What name node does? Name node does metadata information storage. What are the document is being stored at the different data nodes. What client does? Client writes some of the data to the name node server, and that name node server gives information of that file to the name node. Means data node gives information to the name node. These are the files that data node has stored. Then client does read operation. How the client does read operation? It asks for the metadata where that data has been stored in the that data node has storing that information. So name node respond to the client that this is the metadata information, and client automatically goes to that file and read that file. And all these things are being done by automated computing software codes. So it is not like we are doing, means manually these things are not being done. This is fundamental programming level which are being programmed. So I'm explaining you this at the programmers level. So these are the programming done at the Hadoop distributed file system level for communicating name node and data node. So so that a client which is human do not need to go inside looking at the metadata, reading and writing the file. So all this metadata processing and reading writing process is being coded, well coded in the HDFS, and it is just being used by the client. And how it works at the engineering level, this figure explains that engineering level, not the outermost level. And what outermost level look like is like name node is the most intelligent, and then it has two secondary name node could be possible, or there could be 4 5 different secondary node could be possible, but the name node would be the most important master, and which controls different slave node, which is called data node in HDFS. So data node works and operate according to the data nodes work according to the name node. So these are the two things that we had seen in the Hadoop distributed file system, name node and data node. What are the feature of these two things, name node and data node? Name node manages file system, mapping different files, blocks, or some of the data inside the Hadoop distributed file system, and name node manages status of data nodes. And how it manages and maintains the status of data node, it maintains with the help of heartbeat and block report. What is heartbeat? Heartbeat is actually data node keep on sending information that data node is alive and working properly. What is block report? Data node keep on sending the list of blocks that data node has stored, and tells about these are the information whether it is corresponding to the name node or not. So these two are the main important properties and features of name node. Next, what are the responsibilities of data node? Data node actually does replication of different files at the different data nodes. Means there could be the replication could be a 2 machine, 3 machine, or 4 machine, which has been mentioned by the Hadoop distributed file system manager. So manager sends writes that he wants 3 replications. So data node basically do 3 replication over 3 different machines. Why it does so? Because of the failure of one node, disaster could be there, block corruption could be there. So data node do 3 replication, and that three is being mentioned by HDFS manager. Then what data node do? Data node also do data integrity, means check some whether that storage block is correct or not correct, or that checksum is being hidden in some hidden file. And then what third thing does by the data node is rebalancing, means balancing could be done with the different tools, balancer tools, for deletion and new creation, deletion of some file and new creation of new nodes, and decommissioning and management of different nodes working together. So these are the things, been 3 things done by the data node: replication, data integrity, and rebalancing. Name node does management of files in metadata for block management of mapping that block to the data node. Name node also does heartbeat check and block report management. This is the basically replication, block replication way to replicate being done by the data node. So it is storing file 1 in data node 1, data node 3, and then file 2 is being stored at data node 1, data node 2, data node 4. So these are the way and how it has been replicated. This information are being stored in the name node block in the metadata. This is how HDFS data replication takes place. Then we'll see MapReduce. What is MapReduce? MapReduce is basically having two parts. One part is being provided by the user and one part is being provided by the Hadoop framework. What we as a provider, as a user do, we properly write job configuration. We properly write what is the input format and input location of that file that we want to process. What we have to do, we have to do write map function, and in that mapping function is being given to the Hadoop. With that map function, it contains input format and location, and it basically Hadoop distributed framework does splitting and management of that stored data, and which is being processed by the map function. Next, what it Hadoop framework does is splitting and shuffling and management partitioning of all that data being processed with the MapReduce. And then MapReduce does merging and sorting of the result which has been generated by map function coding. Then there could be number of tasks of reduce could be there provided by the user. Then user also writes reduce function which has output key and output type and for the result generation. And then map Hadoop, that's Hadoop framework, actually does start individual reduce processes for merging of the data which has been generated by the map function. And then these results of reduce processing, reduce coding would be generated as collection of the final output being written by the output format which has output format and output location. So how this input and output works with the key and value pair for map key 1 value 1 having generating mapping function processing to generate list key 2 and value 2. What it does reduce does key 2 having different value 2, and list also does key 3 means processing of reduce will generate key 3 with various value 3s. And then map reduce, what it does, map reduce will not function in all these three conditions. Interprocedural communication it doesn't done. Data sharing can't be done at the map reduce. Recursion can't be done with map reduce. This is the basic example of the word count. What we write in the map function, we write breaking of each of the document into different word, and that word would be unique and word should be set as key, and we assign that key with value 1. That one word has been found for this. This is the task of the mapping function, and it outputs each word with value 1 as one word has been found. And then reduce does what, it find out the similar word, same word, and then add all these count 1 value 1 together, so it generated reduce result. For example, input would be deer beer river car river, and then it has been splitted by the Hadoop and as the deer beer river. Then second split is car river. Then mapping would be done based upon the mapper function that we had written. That key would be deer and it has value 1. Key would be beer, it has value 1. Similarly for the data set 2, data set 3. Then this shuffling would be done, that beer will come together, deer will come together, car will come together, river will come together. Then reducing would be done, that beer is being add up, the value inside that beer would be add up. How it does? Value added by value and stored in the value. So what is the value of beer together is 2, what is the value of car together is 3, and this all these things are resulted as the final result. Beer 2, car 3, deer 3, deer 2, river 2. Then next we'll see storm in next class.